So, welcome back to the second session of this video lecture. As in first lecture, I have discussed about the fundamental concepts of bead adsorption isotherm. Now in the second part, now we'll perform the experiment. So I have given the title, it is hands-on demonstration of bead surface area analyzer for determination of specific surface area and the pore size. Because it is a very lengthy experiment. It will take at least 6 to 7 hours. So therefore, I have prepared some part of the experiment on the 29th, 10, 25, and today we will perform the experiment. And as you know that this is a hands-on demonstration, and Dr. Rajiv Nayan will help me. He will actually perform the experiment. And the basic philosophy of this lecture is that in first part I discuss about the fundamental concepts, and you have, I think, understand the theoretical aspects. Now we will put that theory into the practice. And if you understand, then it is very easy for you to perform the experiment. And another objective is that with the help of this video lecture, because large number of research scholars are performing the experiment and some of the MSc students, so they can understand how that bead technique applied experimentally to determine the two important material properties. And today we will determine only two properties. One is specific surface area, and second is the pore size distribution. And as I discussed in my previous lecture, that we are using that Anton-Parr instrument. And you see the specification of the instrument is that we can determine the pore size distribution. The range is very big, 0.35 nanometer to 500 nanometer. And we will perform this experiment in our DST Parse lab. So what are the procedure? First is the how sample is prepared, or the setup of the experiment. And yesterday we have already, weighing part is over. We have already done this part. Today we will just do the degassing, and then of course the original system. And how the instrument model is Anton-Parr AutoSor 6100. And there is a software, so how adsorption, desorption data are collected and used to generate the bead plot through the Kallol software. So, and finally, how we calculate the specific surface. And really I am grateful to the Professor Manas Kanti Dev and Professor Shams Parvez, Professor D.P. Bisen for giving me the opportunity to use that very sophisticated equipment, and it has got paramount importance in the area of environmental science, material science, pharmaceutical science, as well as the nanotechnology. And I am very glad to inform you that large number of faculty members of our departments, as well as some research scholars, they are also working in the area of nanochemistry. And by the end of the session, you should be able to connect the bead theory you learned earlier with its experimental implementation and the data. And let us proceed to the DST Parse lab. It is in the first floor of the chemistry department, and see how theoretical concept transform into real measurable results through the modern instrumentations. And this is the general, I have taken the photographs from this DST Parse lab, and he is Dr. Rajiv Nayan. He will perform the experiment. He did his PhD under the guidance of Dr. Indrapal Kharwal. Now he is a research associate in that project. So as I have already discussed, and when you will see, there are two important parts. First part you see, that is called the analytical analysis station, and there is a transparent glass shield for the protection. And here actually there is only one sample holder here, Here we'll put that sample, and there is a, you see this thing, I will discuss what is the role of this thing. It is called the coolant level sensor, and this is a stand, Dewar flask stand. Here we will keep the nitrogen, liquid nitrogen filled Dewar flask, capacity is 3 liters. So that is the one part. Another part is called the degassing station. It's a very important part. Here there are again two parts. One is heating mantles. You see there are two heating mantles, and this is very important. I will explain. Cold trap Dewar. And third part, that is the whole computer system. The whole instrument is controlled by that computer system using a software. So this is the system, and this Anton PAR we have recently purchased from DST Purse grant, and again I am really acknowledging Professor Dev, coordinator DST Purse project, DST Purse laboratory, and special thanks to Dr. Indrapal Kharwal, Mr. Abhishek Katendra, he is here, and Mr. Vaibhav Dikshit. They are all research scholars. They will help me to perform this experiment, and it is 3-liter liquid nitrogen parts. And now, as I told you that really I have no words to express my deep sense of gratitude to the head of the department also for providing me the facility, because this project comes under this DST Purse promotion of university research and scientific excellence. So we have purchased large number of sophisticated equipments, and in earlier also I discussed about the scanning electron microscope, and in continual we'll do some other very sophisticated instrument for the student as well as the research scholars. Now when we start that software, whatever it is called the block diagram. Now this is a general diagram, but in order to clarity and novelty, you can use this, and I have taken this information from their Anton PAR instruction manual, and you see everything is there. This is the analysis part is also there. Then you see there are two heating mantle, because at a time we can use 6 samples. Here you can see 3. Here 3, front, middle and back. So 3 part is there, and 2 heating mantle. That means in one heating mantle we can put 3 sample tube, but only 1 sample tube is there. So therefore it is 3. Then all types of connectivity, instrumental status, and the name of that software I have already updated and streamlined the Xiaomi software. And this is analysis station, you see, and that sensor is also there. This is tube. I'll show you when we do the experiment. It's a very simple experiment, but of course very, very time consuming, because when we degas this thing, the temperature may be 250 degrees centigrade, and we can go up to 450 degrees centigrade. So in order to cool down that system, so we have to wait for at least 2 hours. Then these are some standard operating system. First is that weighing of the sample. Yesterday we have done all these things. We have prepared the sample. Now we have to weigh before and after degassing. Yes, there may be some loss of the weight. Second part, filling of the coolant, because we have to fill liquid nitrogen in our main Dewar flask as well as that cold trap Dewar. And you should be very, very careful while pouring that liquid nitrogen. Then status of the gas. Large number of gases are required, so there should be no leakage, everything is perfect. Then degassing, and after degassing we perform the analysis, and then again calculation, graphs using the software. And again I am using this from standard analysis procedure, heating mantles, cold trap Dewar. It is available in their instruction manual. Place on the left, everything is there. You will see, you will enjoy all this thing. Now I am coming some fundamental points. When students do experiment, research scholars, they can ask some question. Sir, why there is a need of degassing using that heating mantle? Because you know that the surface must be clean. There should be no contamination. So before measuring the surface area adsorption, the sample must be degassed, very high temperatures. If suppose there is some unabsorbed gas or moisture or contamination, that must be removed. So after degassing, we'll just put a cap. So there should be no contamination. So the goal is to ensure that only adsorption of the gas occurs during the analysis steps. Because very simply, as I told my first lecture, the adsorption isotherm means the adsorption of nitrogen gas on the solid surface at constant temperature with respect to relative pressures. So this is the role of the degassing. Now you can also ask me, sir, what is the use of cold trap dewar? Again, I am just showing you these things. Cold, yes, there is a 2-liter cold trap dewar. Why we pour liquid nitrogen here? So I am just talking about this thing. Just it is for fundamental question for the student, not for the teachers and other things. Because when we apply very high temperature and vacuum, during degassing the cold trap dewar, a container filled with the liquid nitrogen is used to protect the vacuum system and the pump. Because when we apply some high temperature, there must be some evaporation, water or the solvents or the organics, and that are released from the sample during the heating. So what it will prevent the contamination of the vacuum pump and internal tubing by trapping these vapors. There is a condensation process. Because the cold trap, you know that 77 km is minus 196 degrees centigrade, kept at a very low temperature, condenses these vapors into liquids or solid from before they reach the pump. So I think you understand the point. So the roll up. And the last point is that again there is a coolant level sensor, CLS. It must be fitted with that our main tube, sample tube. Because that sensor detects and monitors the amount of liquid nitrogen in the dewar flask. And it is of course related to the temperature stability. If we don't use this coolant level sensor, there may be some problems, calculation, inaccurate results and other things. Because the bit measurement assumes the adsorbed gas, nitrogen at a constant low temperature. And there is no variation. And so the adsorption isotherm can be studied without any problem. So now again let me summarize and we'll just proceed to the DST Prof lab. And when we perform this experiment, you will understand each and everything. So this is a very short information. So again I must summarize that there are two parts. First part I discuss about the I have not derived the bit equation. In next class I maybe derive the bit equation, but here I have given some of the salient features of the bit adsorption isotherm, importance of the specific surface area and some of the part of the, and I am also thankful that I am using the instruction manual of the Anton Par, that bit surface area analyzer. And there are large number of literatures, good books are available in the website. If you want to learn much more about this bit equation, you can. So please come with me, go to the DST Prof lab, which is a very sophisticated lab for experiment. Please come. And you just zoom it, Anton Par. Good afternoon, student. Today we will demonstrate a very important experiment, that is the determination of BET adsorption isotherm and determination of specific surface area of a sample. Now, at the outset, I have no words to express my deep sense of gratitude to Professor Manas Kanti Dev, who is the coordinator of this very prestigious DST PERS project of School of Studies in Chemistry, Pandit Ravi Shankar Shukla University. I am also grateful to the principal investigator, Professor Sams Parvez, as well as Professor Bisen and other scientists for giving us this opportunity to perform a very important experiment with this bit surface area analyzer. And the whole experiment will be performed by Dr. Rajiv Nayan. He is also research associate of this DST PERS project. Now it is one of the very important experiment, and we are really lucky that we are having this Anton Parr beat surface analyzer instrument, and Mr. Vaibhav Dikshit, another research scholar, he is also helping us for photography and other things. So there are two parts. In first part, I have discussed the principle of adsorption isotherm and what are the basic principle of this experiment. And in this part, we will only demonstrate all the things. Now let me first explain the important component of that instrument. Now you see that this is a special type of equipment, and the model is AutoSorb 6100. So it's like our all sophisticated instruments, there are two parts. One part is the main unit, and second part is which is very important, because everything is now controlled by that computer. There is a software, and Dr. Rajiv will tell you the name of that software.
Anton Parr Commie AutoSorb.
This is the actually software. So now the experiment is very easy. That means we can perform the experiment with the help of this software. And another scientist is also here. Please come. You all know that Dr. Indrapal Kharwal. He is also assistant professor, and he is looking after all these instruments and other things. So it's a quite common thing that when we start any experiment, before that we have to perform some of the fundamental things. As you know, there are two important parts. One part is related to the analysis part. You see there is a sample tube, and another is the, you know, that coolant sensor. I think I will explain what is the role of that coolant level sensor. And it is a Dewar flask where we will fill the coolant. We will see the, and here we will use that liquid nitrogen here, coolant. And the another part is very important, because that is the first part of this experiment, that is called the degassing. You see that before doing this experiment, we must degas this thing. So there must be no impurities and other things. And there are, I think, six chambers. But we will use only one system, and there are two heating mantle, because when we will degas it, very high temperature and I think at vacuum there. And you see that there is another part is there, that is also called actually cold trap Dewar. I will also explain the why we use that cold trap Dewar. And third part, you know, that is the software part. So before, there are two parts. First, we will weigh the sample, and Dr. Rajiv will tell you that which type of sample you will take. It may be a solid sample, and basically if you are students of the MSc or the PhD students, you all know about the adsorption isotherm. It is very simple. The amount of extent of the adsorption of a particular solid surface here and that gas we are using is, I think, nitrogen gas.
Yes, liquid.
At temperature must be constant, and the effect of the temperature, that is called the adsorption isotherm. So before we start the experiment, one part is the weighing part. We need a weighing machine, and then we will fill first the liquid nitrogen in the Dewar flask. I think it is 3 liter Dewar flask, and it is that cold trap Dewar. Again, we have to fill the coolant. And now what about the sample tubes? We just want to.
This is the sample tube. This is 9 mm rod. So here we fill the sample. So we take weighing away before and after.
Your sample is solid sample.
Yeah.
And you have a polymer sample or no?
Yeah, it can be polymer also. It can be film also. It cannot be liquid.
Okay.
With the except liquid, anything can be done.
And there are many sample tubes are there.
Like
but it is
previously we have done this cloth. So the fiber
carbon cloth fiber. So it is actually this is actually
degassed.
Degassed.
So
already you have
it is already degassed. So
after you remove all the impurities and everything.
And after removing the moisture, we just cap
it, and then you will just perform the experiment in the analysis. Analysis. This is called the analysis station.
Yes.
And this is actually Dewar flask, where after degassing you have to put that sample.
It will automatically
flow, and there is, I think, adsorption process is also there, desorption process is also there. So it is a very simple experiment. So now what we will do? We'll do before degassing
we have to put the liquid nitrogen.
Okay. So we'll do that part also.
Okay.
Weighing part is over, na?
Weighing part is
over. Okay.
So here we will
yes.
check this.
So you know that for liquid nitrogen handling, we should take some precaution. So therefore we are using that thing. We have to take that also, na? That nitrogen to this cold Dewar, cold trap Dewar. So it is liquid nitrogen, and you know the temperature is 77 Kelvin, minus 186. So we should be very careful while pouring the liquid nitrogen. You see the system. So for degassing process we are using this cold trap Dewar. Because during degassing there may be now we are transferring this liquid nitrogen to our main Dewar flask for our experiment. So it is also coolant, one type of coolant. So that is the first part of this thing. One is degassing part, and then after degassing, we will start the analysis part, the adsorption part. Okay.
गैस होता है थोड़ा इसमें डालना उसको डालना
और डालना पड़ेगा आई थिंक and you see there is a sensor level system, CLS, sensor level coolant level sensor, and that will actually monitor the amount of liquid nitrogen, their pressure and everything is maintained by that, I think, coolant level sensor. Yeah. So now we have filled up the liquid nitrogen and we will start the sample analysis. And now you see this is actually heating mantle for degassing purpose. So there are two heating mantle. Why? Because there are six stations. So in each heating mantle we can use 3 systems for degassing. So there is a system we can just for the demonstration I am showing you. Rajiv will show you.
So this is the sample folder, and here we have removed. So firstly we have to remove this part, and this is called O-ring.
This is the first part, degassing part हम दिखा रहे हैं.
So now we have,
And will maintain the high temperature and it is performed under the vacuum.
so here is two mental, like 1 and 2.
Two mental.
So we are using number 2, and this is,
And because we are using one sample tube.
yeah.
So, but we can simultaneously use 3 also.
Yes.
So 3 here, 3 here, 6.
When the temperature is same for all the sample, we can use all the 3.
Now tell the student what is the use of this cold trap device.
When the moisture will remove out from the sample,
Or maybe some organics is also there.
maybe some volatile. So it cannot go here in sample analysis chamber.
Part.
So here this cold trap will stop that moisture.
So
while
it will
using-
condense all these things
Yeah.
and other things.
So the moisture will condense and it forms a liquid here, and then the cold trap stop that
Stop
moisture.
there. So that part is called the degassing.
Degassing.
Part. Okay.
So now we have to go for here.
Now the software part.
Firstly, we have to connect this instrument. So when we connect this instrument,
Temperature and other things. Yes.
yes. So now it is connected, and we have done connection. This instrumental ID.
Yes, everything is ready.
Yes. So now we have to start.
Yes.
So why we are starting degassing?
Yes.
So we will click degassing,
Degassing.
and it will show which one is mental. So mental 2 is
Mental 2, because there are 2 mental, 1 and 2. So we are using mental 2.
2. So
Yes, 2.
let us
And
make
you
one
see the two.
profile. Yes.
Ah.
Here are 3 sample ID, one front, mid and back. So we are
So you
using
can-
one front.
Front.
Yes. So here is a degassing profile manager. Like we can create new also, and we can use existing ID also.
Right.
So we are going to create new one. So,
And you also create the vacuum, no?
yeah. So the profile name we will enter. Let us say it is carbon cloth.
Carbon cloth.
Yeah. Carbon cloth. So this is the profile name, and now it is already existing.
Okay. No, you can give another name also.
Now this is sample ID. Like suppose it is boron dope carbon cloth. Now we can select. So maybe it can edit. So here, what the sample we have done? We are doing physios option, not chemis option.
Yes.
So it is
that is the
physios
fundamental principle of I have discussed in my theory lecture.
And here is
that
cell
here is
selection.
first thing is that multi-layer, homogeneous, and fissure option. No chemical adsorption.
So it will show what is the type of cell. So we are using uncalibrated cell and 9 mm without filler rod.
Yes.
So we are using 9 mm without
9 mm your
filler rod,
tube.
and we can add here cell weight. So let us weight of cell is 19.429.
And the sample is
Yeah.
So what is the approximate weight of the sample?
0.1469. It means 146 milligram.
146 milligram.
Yes.
Okay, that's fine.
So save and close.
Yes.
Now everything is showing here. What is the maximum
Temperature and
what is the sample ID?
Maximum temperature is
350. It will
350.
reach up to 350. Now
350 degrees centigrade.
yes, 350 degrees. And
So you can understand what is the the role of this cold trap device, because when we impose so many high temperature, so as you told you, there may be some vapors and others they are
so
trapped.
and when we start this degassing, it will automatically start. And here is one log view. Like this is a log view.
Yes.
Now we can see what is the process. Degassing loading is now
Everything
will tell this.
automatic.
So it is
system.
fully automatic.
Automatic system.
Yes. Each and every second, each and every time, it will show the message what is happening inside the instrument. And when we when some error comes, it will automatically stop.
Automatically stop. So now I think students can understand the first part is the after pouring this liquid nitrogen and weighing is also one part. Now degassing is one of the most important part of this type of the experiment, and then of course we'll start the experiment. Okay. Now I think degassing, you have already done it degassing, so we can use this thing. वो जो आपने एक स्ट्रक्चर डायग्राम दिखाया था ना, इसमें उसको एक बार थोड़ा दिखा देते हैं, so that in my theory lecture I have also given this. Please, in my theory lecture I can also giving the details information about these things, and if you see this thing, everything is clear that what I have already discussed, the analysis part, then the degassing part. You see everything is here, that the types of degassing and everything is there. Okay, now we can start the sample analysis. Safety shield, it must be here, so that because all these are very costly things and other things, so to protect any other thing, so we use that part, that is called the safety shield, safety part.
Degassing, maybe it is very hot, but after waiting this, after cooling this, we have to remove. So gradually it will
very slowly we should perform this experiment.
It will take up to 4 to 6 hours to cool down.
It will take at least 4 to 6 hours. 4 से 6 घंटा लगेगा इतना 250 डिग्री सेंटीग्रेड टेम्परेचर को लो करने के लिए.
And after removing the sample, we have to cap this because the moisture cannot go inside.
Yes.
And it is already evacuated. So this should be. Now after degassing, we have to wait again.
Okay.
So how much weight is
lost
after degassing?
So you have a separate weighing balance.
Yeah. So अब इस weighing करके लेना है. So after weighing this sample, we have to put again this analysis chamber. So
now this is the analysis chamber.
Yes.
That is degassing chamber. Here is the analysis chamber. Only one sample can be taken.
Yes.
In our system.
So perfectly we have to do this, and let us check whether it is removing or not. Okay. Now for just do the tie.
We have to just you see the system.
Yes. Now we have to put this.
And there is another system, that is as I CLS.
Yes.
Coolant level sensor, which is very, very important.
This is P0 measurement. So it will automatically.
And this is the stand of that Devar flask.
So now it is
ready for the
analysis. Now we have to take the safety wall.
This is safety wall and safety guard, you can call it.
Safety guard.
Safety shield, you can call it. So you just put this safety. Now everything is ready for the experiment.
So as we have done prior to degassing, like we have to do analysis. So we will go start, and this is what analysis. The same software is there, analysis. Now we have only one station, so it is showing only station one. And we are doing physics option. So again we have to make profile. So as we have profile, so we can create new one also. Carbon cloth. So here the parameter is showing what are the parameter. So we are having a level sensing, analysis temperature, P0 mode monitor, and leak test. This leak test is what? It takes to time, means every 0 to 1 minute it tests leak test whether the gas is leaking or not. So we have it done is 0 because we don't need to leak test, and this pre-analysis volume everything is fine. Gas name, so we can use gas name. It is already
as I
done.
told you that in my introduction part, here we are using nitrogen.
Yes.
But we can also take the organ also. But you know that nitrogen is easily available and very good gas, so we are using. So on that carbon, whatever the material, which is called the adsorbent.
So here we are choosing nitrogen. Here are so many gases
There are so many gases, carbon,
carbon, argon, krypton. So
but nitrogen is best. Where is the nitrogen cylinder? Is the out, there is a cylinder chassis.
Yes.
And you all know the theory of the bit in my introductory part. I have already discussed the difference between the Friend-Lewis adsorption isotherm. Then I also discussed the Langmuir adsorption isotherm. And you know that this bit adsorption isotherm is the extension of that Langmuir adsorption isotherm. Only difference between there that in that system only there is a monolayer system is there. But here, as we increase the pressure of the nitrogen, so there may be multi-layer adsorption. That is the another thing.
So let us check the gas first.
Okay, let us check the gas. That is also very important. These are all very important parts before starting the experiment. There should be no leak and other things, proper pressure and other things. Please come. So now you can understand the seriousness of this experiment, that we have to check everything. These are the all cylinder. You see, this is.
So this is the nitrogen.
This is the nitrogen cylinder. You see, nitrogen.
This is the helium.
This is helium.
And this is the zero air gas, which is helpful for the opening the valve. So here it is.
We check the pressure and other things. Everything we check. There should be no leakage and other things.
It is fine. And it is not opened.
High pure gas, high, because for this adsorption we need very pure gas, because the gas is adsorbed on that surface. So we have to be very careful while handling all these gases. Any problem? Close. You can check the thing. Just the regulator. Now we'll start the experiment. And you see, we'll change the P oblique P naught or P oblique P0. One is saturated pressure, another is the equilibrium pressure. Then of course there is a B adsorption isotherm. I'll show you the formula of that equation. And we can also calculate the specific surface area, pore volume, pore size, everything, and automatically with the help of that. Yes.
So we have done
please
the
come here, Vaibhav.
Profile name, sample ID and file name, and also we have done the pre-weight and post-weight. So here when we start, the analysis is automatically start.
Yes.
So this is the start. Now we can go log view. So this is the log view. Here we can see.
So automatically we can see the effect of pressure and adsorption.
It is now starting target pressure.
इसको ऊपर here I calculation.
So after reaching target pressure, it will go up, and
automatically you will see that we keep this Devar flask on that stand, and you see this is a sample and CLS coolant sensor tube, coolant sensor. It will maintain everything, temperature, everything, and automatically it will increase.
Yeah.
Okay. So in at least you know that it is a very lengthy experiment, because gradually we are using that nitrogen gas. So what I think I will request Dr. Rajiv, he will show some of his old results
Yeah, we can see.
in order to see the types of the adsorption curve, and then how to calculate the surface area, because it will take at least 6 to 8 hours, around 6 to 8 hours
Yes.
to perform the whole
Here is a old
Huh.
graph that we have already done.
Huh.
So here this line is showing adsorption.
This blue line.
Yeah, blue line, and
Huh.
this is called desorption.
Huh.
So by this graph we can
And you see the y-axis. What is y-axis? The amount of
amount of adsorb. And this is the relative pressure.
relative
P by
pressure
P0.
P by P0. One is saturated pressure and another is the equilibrium pressure.
Yes.
So automatically you see this is the very most important curve.
So by using this software we can
Calculate the surface area.
surface area, and here are different methods: BT method, T-plot method. So it is the multiple
BT
BT. So here this is the value of that is surface specific surface area.
You know the unit of
surface
area is the meter square per gram. So you see that
meter square.
his sample total surface area, you see 8.837 meters square. But we are interested in the specific surface area. I will explain in that. So specific surface area is 176.74 meters square per gram. And these are all correlation coefficient and slope and intercept, because you see this relative pressure and that there is a bit
derivative
bit formula. So in order to get the straight line, we are using this adsorption system.
So another we have also done that standard, that is surface area is showing very much high BT method 102.
So very nice
So
curve is observed.
yes.
Now in my first part, I have already explained the theory of this BT equation. Here we have concentrated only on the experimental part. And you see that the system is very simple. Only thing is that we have to take precaution here. And don't worry about the calculations, the graph plotting, everything will be done by that computer. There is a specific software, I think KOME software like that.
Yes,
Ah,
it is
KOME.
highly sophisticated.
Very, very sophisticated, very modern, latest software. And this model is also very good. AutoSort 6100 model. Also in literature, there are a large number of models are available. But it is a great opportunity for the MSc students or the undergraduate student and the research scholar to understand the system. But the basic principle is exactly same thing, like Langmuir adsorption isotherm. One is adsorbate, another is the adsorbent. So it's simply they have prepared some boron doped
carbon
fibers. You can use the silica
nanoparticle.
And what is the importance of this study? Because you all know that there are three types of these substances: mesopores, micropores,
and
like the macropores. And you all know that the recent Nobel Prize on the metal organic framework, these are all such types of porous material,
which is used for the membrane, water filter membrane.
And where that type of surface chemical studies is very, very essential about their pore structure, pore diameter, everything. So you can understand the importance of that.
So in the single machine we calculate all
those parameters. So it is really a great discovery by the three great scientists, Brenner, Emmett and Taylor. So therefore it is called the BT equation. And it was discovered in 1938. So I am really thankful to this head of the department, Professor Dev, and he is also coordinator of, and you can see the instruments and other things. And I am also grateful to Dr. Rajiv Nayan, Dr. Indrapal Kharwal and Vaibhav Dikshit, Abhishek Katendra for demonstrating, and it is only for the student purpose. So you have to understand first the theory, which I have already discussed, and then of course the experimental setup. Remind that first part is the weighing part, and we will use different types of sample tubes. Then second part is the degassing part, because there should be no impurities, nothing. So therefore we are using degassing very high temperature with the heating mantle. And in order to remove all those organics and other things, you are using this cold trap device. And then after this everything is there, then we start this experiment, and it will take 5 to 6 hours gas option analysis, and automatically it will control the adsorption and desorption. And you see that there are two. One is this tube, and it is meant to ensure that these there must be stable liquid nitrogen and low temperature. So there is a sensor, CLS, coolant level sensor. So thank you very much. Thank you. You have to say something?
No.
Okay, thank you.